Hello and welcome to this episode, and in this episode we discuss about a data hierarchy. Data hierarchy means that computers operate on the most simplest form of data. So what is the most simplest form of data? That is bit. That is a bit. That is a form of a 0 or 1. So we can actually represent a 0 or 1 inside of the computer using transistors and other type of electronic components. We can basically represent the most simplest form of data, that is bits. So from there we take bits and we combine those bits, and from the combination of these bits we create what we call characters. So the combination of these bits, for example, a few of these bits come together, 0, 0, 1, 0, 1, 0, and then they can represent a character. A character could be a number, or it could be a representation of a character in the alphabet. So for example, let's assume that this combination of these bits, they represent A of the English alphabet. So from there, the next step is that we make this data more complex and we add a few of bunches of these combination of bits, with which we can usually call it bytes as well. So we combine these bytes, and a few bytes will make up some type of a word. So let's say it makes a word or a name Adam. These words, or this combination of characters, are usually called fields, and this is a field, and this field could represent a name inside of a record. So after these fields we have records where we basically interrelate these fields. So Adam with the first name and Levine maybe with the last name. These two fields, they are combined and they create a record. And finally, by combining many of these records, we can create files. So this is the full name of one person. Maybe we can have the full name of another person, Christina White. So this is another record of a person. And basically the combination of these two records, they will create a file. And usually we can have these files in types of spreadsheets, Word files, Notepad files, any types of files that you can imagine. We create those files, and this is the data hierarchy of how a computer takes the most simplest form of data, or the most simplest form of information that we can convey, that is 0 and 1, and then combining them together. Through this process, it can create files and very complex data structures that could be useful in our daily application of using computers. So that's it for a overall representation of data hierarchy. I just want to go over each one of these data types, the bit, the byte, the field, and records, and all of those one by one. So now that you understand the data hierarchy, let's go and specifically talk about bits in a bit more details. So what is bits? Bits, they stand for binary digits. So it stands for binary digit. And that is exactly what a bit is. It is a binary digit. So in the binary system, we have only two numbers. which is a 0 or 1. We have these two numbers. In our more conventional decimal system, we have our 0, 1, 2, 3, 4, 5 until 9. But in binary system, we only have these two digits, which is a 0 and 1. Using these two digits, we basically represent any number from 0 up until infinity. So 0 and 1 is the most simplest form of data that a computer can store, and it can manipulate as well. So basically all of the calculations that happens inside of a computer, those calculations are based on changing values of 0 to 1 and 1 to 0. So maybe we did some type of an operation to a binary number 001, and that binary number became 101. This is how computers operate. They operate on binary numbers, and then they change these binary numbers to do calculations, and that is where the impressive functions of computers come into play. We might think that computers are very intelligent machines. In fact, they are not that intelligent. They basically change the zeros to ones, ones to zeros, but they do it in a very fast manner. And because of being very fast, it looks to us that computers are intelligent. But basically, this is what computers do in their simplest form of calculation. So now that we have understood that computers operate on a bit level, we as humans, it's very difficult for us to work with bits. So what we like to work with is characters. So let's write down characters in here. Characters. And these characters are digits, for example, 1, 2, 3. Characters include digits, characters includes letters A, B, C, and all of these letters, and also the special type of characters that we have, such as @ slash, parenthesis, and all of these special type of characters that we have. We like to work with these characters because this is how our understanding is, and this combination of characters is on our level of perception and understanding. And because of that, what we do is that we combine bits in a computer level to represent characters. So how do we do that? We do that using a character set. So what we have a character set. So a character set is like the correlation of bit numbers with the characters that we like. So the smallest type of data that we have inside of a computer, it is a 0, right? A representation of 0. Then we say that inside of the character set, this 0 represents, let's say, A. This is not correct, I'm just assuming. Then we say that the next thing that we can represent inside of a computer is 1. Then we say that this 1 could mean B. And then we would make this 0 and 1 more complex, and then we would have 1, 0. The next sequence of numbers that we have inside of a computer. Then we say that this might mean C. And as such, we can represent many different types of characters. And for example, at one point, we have this mix of many different binary digits, and this might mean the special character @. So this is what a character set is. A correlation between the binary digits inside of a computer and the characters that we use to operate on a daily basis. So that's how a character set is created. So the standard character set that the C programming language uses, it's called ASCII. ASCII. So ASCII stands for the American Standard Code for Information Interchange. So this is what the ASCII character set stands for, and this is a character set that correlates the binary numbers or the representation of the binary numbers with the characters that we are used to, and we would like to use these characters to work with computers. Now let's go and see the ASCII character set on my computer. So here we are on my laptop, and now we are in Google and we want to search for the ASCII character set. Let's go here in a W3 Schools website and open the ASCII reference in here. You can see that the ASCII characters from 0 to 31, they are control characters, and we do not have a printable representation of those characters, but after 32 we have those printable representation of the characters. 32 stands for space, 33 exclamation mark. You can see that we have the digits and then semicolon and then uppercase A 65, uppercase B 66. And the C programming language basically uses this character set to represent all of these characters. Now to show you that, let's go here to our IDE, and then I want to print a number. Let's go and print this number integer. And what is this number? This number could be 76, right? Let's go and print this number. Let's go and execute this program, and we get the 76 representation, the integer representation of this number, right? Now, instead of the integer representation, we want to see the character representation of this number. So we will use the conversion specifier for a character. Now the 76 translates to L, capital letter L, 76. If we go to our character set in here, 76 exactly stands for upper L. And that is how characters are being formed in computers, and also they are being represented in C programming language. So up until now we have talked about bits and we have also talked about characters. Now it's time to talk about fields. So fields are basically a combination of characters so that they convey something meaningful. So characters, they come together to create something meaningful. For example, Adam. Adam is a name, and this name is basically a field. So it is a combination of characters, many different characters. They have come together to create the field to convey something meaningful. Now we can interrelate two different fields. For example, the name in here, and then another field that we have, it represents age, 23. So the name Adam and the age 23, they are being combined to one another, and they create the record for a person. So the record for Adam is, his name is Adam and his age is 23. And then we have another record for Christina. Christina, her name is Christina and her age is 33. Now, if we take these two records and we combine them together with one another, what we get is a file. Now let's go and see these concepts in my computer once again. So here in the C programming language, to represent fields, we have used numbers until now that you have seen many times. For example, age of somebody could be 23. This you have seen, but maybe if we want to represent their name, then we can combine some characters and we can make strings. So we haven't really studied strings yet, but just for the time being, I'm just mentioning it for you. So now that we have created our fields in C programming language, we can combine them together and interrelate them using arrays. Arrays we also haven't studied yet, so later on we will study it. And finally, we will combine these records and we can save them into files. And file is also a topic that we will later on study during this series. But for the time being, it's much easier for me if I show these concepts for you here in Excel. So let's go to Excel, create a blank sheet, and then I have this field which represents a name, the name Adam, and then the next field represents the age, and then these two fields, they create a record. Let's create another record, Christina, and then her age is 33, and this is another record, this is one record, this is another record, and the combination of these records basically creates a sheet, or we can say that it creates an Excel file, and we can basically go and save this file as an Excel file. So that is how I can maybe easily convey for you how fields, records, and files could be represented in computers.